Hey everyone, we're moving on to Chapter 9. This section is on correlation and regression. So we'll start with correlation, which is 9.1. Correlation just meaning a relationship between two variables. So the way we're going to set this up is we're going to be thinking of ordered pairs x and y, and we're going to plot them on a scatter plot. You might remember those from Chapter 2. If not, we'll be looking at a lot of them in this chapter. We have two types of variables. We have the explanatory variable x, and we're going to put that on the horizontal axis. And then we have the response variable y on the vertical axis. That's going to generate a scatter plot. And then we're going to look for any sort of trends in the data. So looking at some examples of different types of patterns we'll see. Look at this first one, a negative linear correlation. Notice what's happening here as x increases, y tends to decrease, which creates this sort of downward trend, right? So if we look at like a specific dot, say, about this one right here, right? Notice that one has a pretty large x value on the x-axis, right? But a very small y value, right? So that's why this is a negative correlation. Vice versa, like say this dot has a pretty small correlation x value, right? And then on the y is pretty high, right? So they're kind of opposites, right? As x gets big, y gets small, vice versa. For positive linear, we could see it's the opposite, or as x increases, so does y. So they both increase together. That creates that upward trend, or we're calling positive linear correlation. The next one, there's no correlation, right? Just the dots are scattered all over the place. Or we could have a nonlinear, which is a pattern, but it's just not in a straight line. In this case, it's parabolic. All right, let's associate these with some real-world data. So for each of the following, what type of correlation would you expect? Right? So if we look at stats versus college GPA, SAT scores versus SAT scores versus college GPA, what kind of correlation would you expect? Well, you would expect as SAT scores rise, so would college GPA. So they would rise together. That would give that positive trend, right? As x increases, y tends to increase as well. So that would be a positive correlation. Height and IQ, we wouldn't expect anything, right? We wouldn't expect height to determine a person's intelligence quotient. So that's no correlation. Absences versus test score, there's a good example of negative correlation, because as absences rise, test scores tend to go down, right? And then finally, average monthly temperature versus month of the year. So if this is the month of the year, as we go from January up to the summer months, the temperature's rising, and then it falls again down to December, right? So that gives us a nonlinear correlation, or more specifically, a parabolic correlation. Okay. Let's look at a data set. Here we have a study. We have age of men versus systolic blood pressure, and we're looking at if there's any sort of patterns in the data. So it says, let's display this data in a scatter plot and describe the correlation. So to do the scatter plot, we're going to use technology as opposed to drawing it by hand. And let's load that into a StatCrunch. StatCrunch could do that for us. So I have StatCrunch here. I can open it up. And where it's located is graphs. Right? I can click on graph, scatter plot. Well, first I have to load the data, don't I? Duh. All right, sorry about that. So let's load the data. I put that under my groups folder. So it's under, I think it's on the third page is all the chapter 9 stuff now. So there it is, age versus blood pressure. Okay, so yeah, got to have some numbers in there before you graph anything. So I load the data in. Now I can go to graph, scatter plot, and then all I got to do is select my columns for the X and the Y. I'm not going to do any of the other fancy stuff, and just click compute, and I get a pretty good looking scatter plot. And now I can see there's a trend, a positive linear correlation. I see the dots rising from left to right, and I have the graphs labeled on the axes, which is nice. Okay, so I can go back to my handout, and I could say, yeah, this is definitely a positive correlation. Linear correlation. Right. Okay, I'm gonna rewrite that. Now the next thing is, how strong is that correlation? I mean, we got some scatter involved, right? It's not a perfect line, but is it a lot of scatter, a little scatter, right? How good is this model at predicting values? Well, there's a tool that you can use to measure the strength of a scatter plot or a correlation, and that's called the correlation coefficient. It's denoted by R, and it measures the strength and direction of a linear relationship. It has a formula, and this formula is there just for admiration, I guess. We're not really going to use this formula. It takes a long time to actually do the calculation, because look at all those summations. So you would use tables and et cetera, et cetera. We're just going to rely on technology for the calculation, and then our focus on the class is the interpretation of that number. So once you get that R, it's going to have a range. It's going to range from -1 to 1. So it's always going to be somewhere between -1 and 1. If the variables have a strong positive linear correlation, then R is going to be close to 1. If they have a strong negative correlation, then R is close to -1. And if you have no correlation, it's going to be close to 0. So the extreme cases are graphed here. Right, here's R equals -1, perfect straight line trending downward. In the middle is R equals 0, just no pattern at all. And then R equals 1, perfect linear trend upwards. Beyond that, like say you had R equals 0.9, well, then you're going to have a little bit of scatter involved, and there's still a strong correlation. It's just not perfect. So if we start thinking about some ranges of numbers, maybe something like 0.8 to 1, I would call strong. And that could be plus or minus, right? The minus just indicates it's trending down. So a -0.9 would still be strong. It would just be a negative correlation. If we get down to like 0.4, maybe 0.8, we can call that moderate, plus or minus. Once we get down to like the lower numbers, like 0.1 to 0.4 in there, that's pretty weak. I mean, there's still some linear trend there, but not a lot. And then once you get below 0.1, like anything in that range, we're just really not seeing anything. Okay. If you wanted to get a feel for the R, there's a good applet in StatCrunch. If you go, let's close out of that, get just a regular page, open StatCrunch like a blank spreadsheet. If you go to applets, you'll see on the fourth one down, correlation by I. And you can just click on compute, and it gives you a random scatter plot. And you can guess what you think that R would be, or you could just show it. Right? And that's 0.34. So it's showing maybe some positive trend, but it's pretty weak. And it's sample size of 20. And then if you want to add more dots, you can just by clicking on them. Right? Notice the more you put sort of on a straight line, you can see that correlation coefficient rise. Okay? Or you can reset it and do another one, right? And just do a bunch of random scatter plots to get a feel for, what R values correlate to what the scatter plot looks like. But that's something to, play around with if you'd like to. Okay, back to the handout. Let's use StatCrunch to find R. So that's the next goal. So how do we do that? Well, you got to load the data in there. Did I close that data out? Probably. So we'll start over. We're going into my groups. Got to load the data. I'm getting pretty fast at this now. Okay, age versus blood pressure. Now, where this is located is where a lot of stuff has been located this semester under stat. So click on the stat menu. We've done calculators and z-stat and t-stat proportion. We're doing now what's called regression. So click on regression, and then the one you're going to choose is simple linear. That's all we're going to focus on in this chapter. So simple linear, and really all you got to do is just select the appropriate columns, X and Y. Don't worry about all the rest, and click compute. It gives you an output of a lot of things. All we're really focused on now is that correlation coefficient, which in StatCrunch it's a capital R, in the textbook it's lowercase r. Those are the same thing. But here I see that R, about 6 lines down there, correlation coefficient is 0.908. So it's detecting a strong correlation between age and blood pressure. If you click the arrow to the right above, you'll see that there is the scatter plot as well, like we already looked at, but also puts in that fitted line, and we can see that a lot of the dots are really close to that line. So that's why we're indicating a strong correlation. Okay, so I'm going to write down that number, 0.908, my handout. Oh, I can't do that in highlighter. And what kind of correlation is that? Now we have a lot of adjectives. The main 3 adjectives are strong, positive, linear correlation. Okay. So strong because it's greater than 0.8, positive because R is a positive number. If I got R equals a negative number, then that would be a negative correlation. And then R always detects linear, so it's always linear. Okay, that's a good stopping point for now. In the next video, I'll finish up 9.1, but hope all is well. Send emails my way if you have any questions. Talk to you next time. Thanks. Bye.